given this one, okay, in order to solve this, we integrate first. Already, right? This one inside the brackets is linear x plus 2. Degree power 1. Yeah, the power is 1. If it is not of your ax plus b form, then you have to expect. Okay. Alright, question 10. So this one solve itself. Do we need to expand this one to solve? No need all. Okay, we just give it, right? Otherwise, you go into solving cubic equation, that will be inefficient. Okay, question 10, part I. We want to show, okay, that expression. Are you able to show it? For question 10, can show? Can show, okay, so then I'll go into part 2. Right? So, we are able to show this already. Part 2. Okay, the thing about question 10 is that it is not a differentiation followed by integration. Okay, so what you did in part I is to show that this expression is equals to this. So what we can do is that instead of focusing on integrating this function, we are looking at integrating this function instead, because these expressions are equal. Alright? So for 1 plus sine 4x, we know how to go about integrating it. Okay, for integrating 1, we will get back our x. And to integrate sine, that means our negative cosine. Angle remains the same, not forgetting to divide it by 4. Okay, then bounded by 0 to pi over 2. Okay, so therefore, you put in the values, okay, and you will get pi over 2 minus 1/4 minus 0 minus 1/4. Okay, eventually you should get pi over 2. Right? Okay, so I hope that you're not mistaken by what part I is telling us. Okay, part I is not a differentiation question. Differentiation is doable. We apply our product rule, and then we will get 4x e to the power 2x plus 2e to the power 2x. It's a product of two things. We have 2x and e to the power 2x. Yeah? Okay. Then in part 2 itself, we want to show that the integration of 2x e to the power 2x gives us this. Okay. So to make use of question 12 part I, right, we need to observe how can I find this in our part I, and that can be found over here. Just that this is a 4 and this is a 2. Okay, that means that we need to do some multiplication of 2 or division by 2 later on. Right? So we do as per usual. We write down what we understand from part I. That is when we integrate the right side over here, we will be getting back the original function followed by a plus c. Okay, I'm leaving out out the definite integral part. So I'm leaving out the boundaries so that it will be easier for us to manipulate first. Okay, then we can break out this integral into two parts. Okay, into as such, and then we want this to be our subject, so this one will move it to the right side. Okay, and to integrate 2e to the power of 2x, we know that it will give us 2e to the power of 2x divided by 2. Okay, I just take this plus c and integrating this will give us another constant, so I'm just going to put them all together as a plus a. Okay. Right, so at this stage we know that integrating 4x e to the power of 2x will give us this expression. Okay, so we are actually only one step away to get this value, or actually not one step, so a few more steps. Okay, so that will mean that we have to divide by 2. So this is 2 times 2x e x. So dividing by 2, I will have x e to the power of 2x minus away e to the power of 2x over 2. Our plus d will divide by 2. I'll just change it to a plus f. Okay. And now we put in the definite integrals. So I've do away with the plus f already. I'll just put in the boundaries of 0 to 1. Okay, so substitute in the values, we will get 1 times e to the power 2 minus e to the power 2 over 2. Minus away 0, minus away half. So e square minus half e square, that will give us half e square plus half. Then we put it into the same denominator. So, yeah, we are able to show it. Any questions? Okay, go with question 2 and question 12. Let's take a look at question 13, okay? Question 13, I hope that the partial fraction part is okay. Can Alright, so then looking at part 2, okay, what we will do is to apply the partial fraction into the integral, or rather the expression that we want to integrate. Okay? So integrating your 1 over x plus 2 and your 1 over x plus 1, that will give us ln. Then to integrate our 1 over x plus 1 square, that is actually your x plus 1 to the power of negative 2. So that will be power plus 1, that's negative 1 divided by negative 1. Okay? So we get this. Then we simplify first. Since there's two logarithms subtracting each other, that means that I can simplify it into x plus 2 over x plus 1. Okay? We'll write it into a single logarithm. Then we will get minus away x plus 1 in the denominator. Okay? Then we substitute in the values. 3 plus 2, 5 over 4 minus away 1/4 minus away 1. Okay. So our goal is to arrive at ln 5 over 8. That is because ln 5 over 4 minus away ln 2 is the same as ln 5 over 4 divided by 2. And minus 1/4 plus 1 is 3/4. So a little test of your logarithm laws for that. Okay? And then you get the answer. Okay, any other questions? Okay, due to the time factor, could you please submit your homework to Mingsan by the end of today? Okay, Mingsan, attention over here, not at the voice please. Okay, help me to collect the homework, alright, by the end of today. Okay, 17.1. Alright, so there I can finish up some examples for 17.2. Okay, before addressing the problems you have for 17.3 from yesterday. Okay. and finish that up. Because I still have some questions I want to cover. In our last lesson, when it came to this topic, we have already learned how to find area that is below the curve to the x-axis, okay, or from the curve to the x-axis if the curve is under the x-axis itself. Okay, otherwise, so these are the three things that we have looked at now. Okay, finding out area like that. Okay, finding area that is below the x-axis. And then also, we have learned how to find maybe okay, to the y-axis itself as well. Okay? So we looked at these three different cases over here. Okay, whereas the very first case, right, to find out what is the area, we are integrating our fx from a to b. Okay, and then for this one, it will still be from a to b, just that we have to apply the negative sign, because it is below the x-axis. And then when we integrate towards the y-axis, okay, we have to make x a subject for the function and then integrate from c to d, where c and d are values on the y-axis itself. Okay, so these are the three cases. I want us to take a look at exercise 17.2, question 9. Okay, so looking at question 9 itself, right, it's not our usual conventional question where we want to find area. Okay, so we are given this curve where y equals to fx, and given that there are points on this curve itself, the points are p, q, and r, we want to find out what is the value of 3 to 6, okay, when we integrate y with respect to x, and also integrating from 2 to 9, okay, integrating x with respect to y. Okay, first of all, it requires very, very strong understanding about what this expression actually is asking you to do. Okay, very likely, you might be starting to think, oh, maybe I can integrate y, and then you start to do y squared over 2. Okay, that's not correct because you're trying to integrate with respect to x. So do pay attention to that. And then over here, we're integrating with respect to y. Okay, so you cannot say that it is actually y squared over 2, 6 to 3, and then x squared over 2, 9 to 2. This is not correct because of the things that we're supposed to integrate with respect to. this is supposed to be with respect to x. Okay, so what it's trying to say is that when we want to integrate y with respect to x for the boundary 3 to 6, that is actually telling you that we're trying to integrate this function y, okay, which can be expressed as fx, but we do not know what is fx, 3 to 6. So that means that our boundary x is 3 over here, 6 is over here. Okay, so since you're integrating respect to x, that is meaning to say we're trying to find out what is this area. You understand? Okay, and then when I want to integrate from 2 to 9, integrate x with respect to y, that means that we're looking for, okay, 2 is actually over here because of the y coordinate of p, and based on the y coordinate of r, 9 is over here. So we're actually trying to get this area here. Okay, so this part matches to the red area, and this part matches to the blue area. Okay, so since you're trying to find the sum of the two areas, okay, and the fact that we do not know what is the expression of the function, okay, how then are we supposed to find the sum of these two areas? Okay, it requires us to take things in a different perspective now. Okay, we're trying to see it in a geometrical manner. We recognize that there is a big rectangle over here. The two areas that we want to find can be seen as taking the big rectangle minus away this empty rectangle. Do you all see it? Okay, so you need to draw that link that this is telling us this area and this is telling us this area. Don't see it separately, see it as a sum. Okay, and then you can see that it's big rectangle minus small rectangle. So this question did not require us to use any form of integration, but to link our understanding about definite integrals to area and then see things in terms of area. So it will be your big rectangle that will be base breadth and length 6 times 9 minus away the small rectangle 3 times 2. Okay. And therefore we will get 54 minus away 6. Hence 48 units squared. For that one, for the question 9. Okay, understand, right? Okay, let's look at try 12. Okay, so as mentioned before, don't expect that they will always shade the area for you. You must be able to interpret from the question, okay, where are you supposed to find for the area. So in the question itself, they have given you this diagram and they want you to find an area of the region that is bounded by the coordinate axis. Okay, by coordinate axis, they are trying to refer to the x-axis as well as the y-axis. The line MN, so MN is this line here. Okay, and we're being bounded by your axis like that. And then also bounded by the curve. So there's this extra boundary over here. That will mean that the area that we're trying to find is this area here. Okay? So first step is to always identify what is the area that we're trying to find. Okay? Then we observe that the function given to us is x equals to 2y squared plus 1. Okay? So it depends on how we want to break up this area in order to solve the question. So some of you may start thinking of seeing this entire trapezium here. Okay, then try to minus away this part. Okay, I'm not sure whether you can see there's a trapezium. Trapezium has one pair of parallel lines, this one parallel. Okay, so you might think of taking the trapezium minus away this. But is it the best option? If I want to find out what is this purple area, that means that I want to integrate my function with respect to x because we're integrating towards the x-axis. We're trying to find area towards x-axis. But then, for us to integrate this, okay, with respect to x, my expression over here is in terms of y. So that's not very convenient, okay, unless you do a little bit of manipulation. Right? But even manipulating, okay, not very convenient because of the square, you later on have to take square root. Okay? So that is an option that we don't want to actually explore. Then how? Okay? We will think about integrating with respect to the y-axis. Okay? And to do that, we have to divide the area that we're trying to find, okay, into two parts. Okay? So one is for the curve itself towards the y-axis. I need to find out what is this value so that I have the boundary of 0 to this value. Okay? Then, for this additional part on top, it is none other than just a triangle. Okay? So, to find the area of the triangle, likewise, I need to know this value and I need to know this value as well. Okay? So that I can do half times base times height. Right? So, there are two coordinate points that I need to find. Okay, or rather two values that I need to find, and that coordinate point is this one over here. Okay, this point is the intersection of the curve with the straight line MN. Right? Question did not give us the equation of the straight line MN, but then it's not difficult to find. Okay, since we have the coordinates of M and N. So gradient of MN . We can deduce that the equation of Mn is y equals to negative x plus 4. In case you're wondering how come I never do the plus c thing, that's because I already know the y-intercept of this straight line that is at 4. Okay? So I don't need to go and do the substitution of values in order for us to form the equation. So we have this first equation. And my curve equation, I solve them simultaneously in order for us to find out some x equal to 1. In order to find out what is the intersection point. Okay, so I'm substituting 1 into 2. That means my y, I change it into negative x plus 4. Okay? Very often when it comes to expansion of expressions like that, when it is a negative, okay, there's a lot of careless mistakes usually. I would rather you just see it as the equivalence 4 minus x squared, something more familiar, easier for you to actually expand using your identity. So we get 16 minus 8x plus x squared. x to the right side, we are looking at solving a quadratic equation, 2x squared minus 17x plus 33. And with factorization, we have 2x minus 11 and x minus 3. Okay. Then now, that means that x equals to 11 over 2 or x equals to 3. Okay, 11 over 2, that is your 5.5. Okay, both are positive values. Yeah. Huh? Minus. Which step are you looking at? Sorry, any question? No, okay. So both of these x values are positive. Okay, 5.5 and 3. So how then do we decide? Okay, you always have this tendency that when you see negative, you automatically reject. That shouldn't be the case also. We need to draw link, okay, to the question context. Okay, so looking at the question context itself, which value do you think is sensible for it to be this point? It should be 3. Okay, why? Because n40 is over here. Okay, so you expect this value to be lesser than 4. Right, so that's why we don't take 5.5. Okay, so the reason is because the intersection point is before n40. Okay, so we will take x equals to 3 to find out what is the y value, and that is equals to 1. So we found that this is 3 and this is 1. Okay, and now we can proceed to find out what is the area . So we will be integrating our function 2y squared plus 1. Okay. Finding this part here, we'll be integrating from 0 to 1 with respect to y. Then we add in the area of the triangle. That will be half times base is 3 units, height is also 3 units. So the blue part and the red part. Okay. Then we can solve by integrating 2y squared into 2y cubed over 3 plus y. Half times 3 times 3, that will be 9 over 2, so 4.5. Sub in 1 and then sub in 0. Sub in 0 you get 0. So 1 and 2/3 plus 4.5. You will get 6 and 1 over 6. Okay. Any questions? Right? regarding this triangle, right? Okay, there is also another way to find out what is the area of this triangle. That is by integration. Okay, so if you want to, which is slightly more complicated and tedious, you can, based on the equation of this line here, which we have found to be y equals to negative x plus 4, we got to make x the subject so that we get x equals to 4 minus y. Integrate with respect to y from 1 to 4. Okay, so there's an alternative via integration. You will get the same answer. But I usually wouldn't want us to do this, okay, because it is troublesome now. You have to make x a subject. Okay, so when it comes to lines and you can see your usual geometrical shapes, like your triangle, your trapezium, okay, then we go with that area of triangle and area of trapezium, or rectangle, square, whatsoever. Okay, rather than doing integration, because that adds another layer of complication. Okay. Yeah. Why what? Down here got one x. Okay. So exercise 17.2 homework. Question 5, 6, 10, 11. Okay, similar deadline to your exercise 17.3, which I posted on your SLS and your Google Classroom. Okay, that is due, this one is before 29 May inside my locker. Okay, for exercise 17.3, there will be question 2A, 3, and 6. Okay, likewise, before 29 May inside my locker. Okay. I don't have the time to address the questions in your SLS, okay, but I did notice the poll that you all have done. Okay, it is certain questions that you are not quite sure of, right? And it's not the majority also. Okay. I think due to the time factor, okay, if for these people that say that you need me to readdress any problems, may I suggest that you look for me separately after class, okay? Then I can address it with you again. Okay? Can we do that? Right, thereafter, people who have not yet done the SLS, please go and get it done, okay? Because so that I don't need to repeat myself. Since the next time I see you will be, what, 4 weeks later already.